I hope the screen is visible to you. The same discussion yesterday, which has happened about regular expressions. As before learning regular expressions, we just have a look into regular language. Regular language is a language can accepted by any of the machine. Right now we know about three machines: DFA, NFA, and epsilon NFA. Right. So if what is the language that is accepted by your finite automata and epsilon finite automata, the language is nothing but your regular language. And what is the use of regular expressions in regular language is to represent your regular language, we will be using the regular expressions. Means a regular language can be described using the regular expressions. And these regular expressions will consist of not only the alphabetical symbols. Along with the alphabetical symbols, we use few symbols are called operators, called a dot operator, plus operator, and then star. And here the dot operator is useful for concatenation purpose. Suppose if I write two languages, L1 dot L2, I am trying to concatenate these two languages and I will just get the resultant language concatenation of these two. And A plus B is union operator. I'm going to union those two things, combine those two things based on the OR purpose. And then coming to the the star operator never has two operands. Always the closure is going to be applicable only on a single operand. Suppose I can write R1 star or else R2 star. Means the closure includes zero or more number of symbols in it, right? Zero or more combinations of symbols in it. 1 second, let me try to admit people. Fine. And out of this, when you consider about the priorities, the least priority goes to your union operator. The dot operator has the next least priority. The highest priority always you have to consider about the closure, means star. Apart from these plus dot and then star operators, you have open and closed parenthesis symbols also you can see in a regular expression. Then just we'll straight away move towards regular expression definition. See, you can define a regular expression in four ways. Means uh, here, four type of regular expressions possible. Initially starting with an empty language, a language doesn't contain anything apart from curly braces. We just represent an empty language with a phi symbol. I mean the null symbol. Even the phi is also a regular expression. Then not only empty language, empty input. We always represent our empty input string as epsilon. Even epsilon is also a regular expression. So not only empty language, empty input string, and coming to the basic length, I'll give it length 1. Your any alphabet symbols A, B, C like that, length 1 alphabets are also the regular expressions. So right now we have seen null string, null language, empty string, and then one length alphabets, right, as a regular expression. So not only this, when I'm performing union, concatenation, and closure operations over two different languages, the resultant language also possesses the regular expression. So that is what I'm trying to say in my rule 4. If R is a regular expression denoting the language LR, and S is a regular expression denoting the language LS. I have taken two different languages here, LR and LS. So LR has the regular expression R. LS is a language which possesses the regular expression S. Already I told you, we will be using regular expressions to describe the languages. Right? Earlier, the language is nothing but the set of all strings possible. Here, in this module, I can say that a language can possess the pattern. Suppose we say a language contains n number of strings, right? Each string has its own pattern, right? That comes under a language. So that who is going to describe about the pattern is nothing but the expression that it has, regular expression. See, in this fourth rule, when I perform an union operation, concatenation operation, or the closure operation on any regular expression, the resulting language also possesses the regular expression. So what is in the fifth rule says this? The following expressions obtained in the four applying rules from 1 to 4 are all are regular expressions. Whenever it is asked on the question paper, define a regular expression, don't limit your answer telling only one statement. All these four has to come. Empty language, empty string, string length of 1, and then operations, union, concatenation, and then closure. So any doubt in regular expression definition?
No, ma'am.
Fine. So now let me open the Jamboard. If it is visible, let me know. Yes. 1 second. We'll go for writing few regular expressions. Is the Jamboard is visible?
Yes, ma'am.
Yes,
Fine,
ma'am.
fine, fine. So I think yesterday there is a question. Ishaka?
Yes, ma'am.
Day before yesterday. What is the question? Can you repeat?
Yes, ma'am.
I think even number
Ma'am,
of
even
ones.
yes, ma'am. And 0 should be a multiple of 3.
Okay, multiple of 3. So number of ones are even. So both should be, because and as there in the question, I think you have to write a single DFA. For a single DFA, I'll just write like this. Let
Ma'am,
my
sorry, even
starts.
number of ones and zeros is a multiple of 3. Yes.
Okay, fine. Anything. Not a worry. So first let me go with ones, even number of ones. Mm, zero number of ones is also acceptable, right? So what
Yes,
I
ma'am.
do is I'll just make my initial state itself as the final state because zero number of ones is also even number of ones. For an odd number of one, it will go to the state called Q1, right? It will go to the state called Q1. This is not a final state. And again for Q1, I will try to provide one more one. So this loop is there every time when it ends at Q0, it results in even number of ones. Zero number of ones is also even, 1 and then again 1. 2 number of ones is also even, 3, 4. So all multiples of 2 means even number of ones will end up with Q0, which is the final state. Is that fine? Okay. The same DFSM I have to implement for multiple of zeros, length should be multiple of 3. So I already had a final state Q naught. Let me not go to one more final state because I have told you the optimal DFSM should not contain more number of final states until unless it is actually required. So now what I have to do is for the same, for Q naught, you can have to remember I didn't give any zero input, right? One input I have given. I'll go with a zero input. So multiples of 3s are what? 0 multiple 3, 0 mod 3, 3 mod 3, 6 mod 3, 9 mod 3, all the multiples. So I'll go to a state called Q2. I'll go to a state called Q2 for 1 0. And for one more 0, I will go to a state called Q3. So this will result with the 2 zeros. And for the third 0, it has to be the final state. Final state already Q naught. I will take a 0 here. So 0 mod 3 0, 1 mod 3, 2 mod 3, 2 mod 3, 3 mod 3. So 3 mod 3 final state. 4, 5, 6 mod 3 final state. Is that okay?
Yes, ma'am.
Okay. So remaining inputs you try to provide to the what to say, dead state. So for Q naught I have provided 1 and 0. For Q1 I haven't provided 0. So after 1, I think here you can make a dead state or else you can leave the problem here also. So don't worry, you can convince. So I'll go with a state called Q4, which is the dead state. for any input. So provide your other than that. Mention that it's a dead state, 0. And then remaining inputs, make it to Q4. Fine?
Yes, ma'am.
Okay. And when you're answering the IA test 1 question paper, I require all the tuples to be satisfied. If a question has been asked to construct a DFSM, don't simply draw the transition diagram and then leave. So 5 tuples are there. Q, what is the Q? Number of finite states. Sigma, number of input alphabets, here 0, 1. What is Q here? Big Q. Q0, Q1, Q2, Q3. So you have to mention big Q is equal to set of all states, right? Within the curly braces, mention Q0, comma, Q1, comma, like that. Q sigma del. So when it comes to the transition table, you can write the transition table on the inputs. First column states. Mention the start state and final state with arrow mark and then this thing. Q sigma del. What is your start state here? Next tuple is Q naught. What is your final state? The final state is also Q naught. You can write the final state belongs to Q naught. Fine. All these tuples are required for presenting a question. Okay. Now we'll go to few regular expressions which is really required to understand a regular language. Okay, let me tell you about how do you represent the string consisting of any number of A's. The string consisting of any number of A's. I need your answers. Any number of A's. Including any number of A's means what? 0 number of A's. Yes. What about A star? I'm asking about the string, right? What about A star? Don't it allow any number of A's?
Yes, ma'am.
Okay, the next one. The string consisting of at least one A. At least one A should be there. At least one A means at least one A. So A star I cannot include because A star will include epsilon also, right? Minimum A should be there. What is then? It is
A plus.
A plus. Fine. What is next is string consisting of either 1A or 1B. See, all these basic requirements are required. String consisting of 1A or 1B. I didn't ask about multiple, 1A, 1B. How can I write? 1A or R means what? Concatenation. 1A or 1B. So A plus B means what? So is it a regular expression now? I have the symbol A, I have the symbol B, I have the symbol plus, I have the symbol parenthesis. Either A is accepted, 1A or 1B is accepted. A string consisting of 1A or 1B. What about set of all strings of A's and B's of any length, including the null string? Set of all strings of A's and B's. So here your input alphabets are what? A's and B's of any length. Of any length in the sense which includes what it will include? Epsilon also. So for that, A's and B's, right? Any number of A's and B's. So either A or B, both will include. I have to make a star. So set of strings of A's and B's of any length, including the null string. So this will include the null string also. So your next question is the set of strings of A's and B's ending with the string ABB. The set of strings of A's and B's ending with the string ABB. For the same thing, you can write a DFA also. That's what I told you. Whatever regular expressions I'm writing right now, for all the regular expressions, you can develop a DFA. So if you develop a DFA for a regular expression in the sense, any DFA which accepts a language that you can write that is a regular language actually. You can write a regular expression. Fine. I'm not getting any answers. Why? Can you tell me the strings of A's and B's that ending with ABB?
Ma'am, ABB, AABB, or any, we can add any.
No. Here I don't want strings. I need a regular expression.
A plus B star
Yeah.
ABB.
A plus B ending with ABB, right? Ending with ABB when the length is null, even ABB is a one of the string. Or it may be with A power n ABB or B power n ABB. So that's why there is a star over here. So ending with ABB. So the set of all strings of A's and B's of any length ending with ABB. Okay, the strings of A's and B's starting with the string AB. Strings of A's and B's starting with AB. It's very simple. Starting with AB, followed with anything. Could be null string also. So what I have to do? I have to make a star. If you get a keyword called at least one, so that at least one A, at least one B, that time the plus comes because the plus is clean plus one or more number of symbols, whereas closure is zero or more number of symbols possible. Right? Set of strings of A's and B's having the substring AA. So here substring AA. Substring, you know, right? That may occur at the start, middle, or at the end. Substring AA. So for this, I will write like this: A plus B star AA followed with one more A plus B star. What does it represents? If you want that AA to occur first, consider this A plus B whole star as epsilon. Consider this as epsilon. Because star is there, no? The AA will be at the starting of the string. Suppose if you want this middle, give the length 1 to this, length 1 or more to this, so that AA will be in the middle. Suppose you want that AA substring to be at the end, AA to be at the end. So consider the first A plus B whole star with a minimal possible length, and then AA, make it as epsilon. So substring AA. Okay. So the next one is, at least for this you tell me, I'll write the regular expression A star followed with B star and then followed with C star. So any number of A's, set of all possible strings of A's, B's, C's, any number of strings that any number of A's followed by any number of B's followed by any number of C's. So minimal string to be accepted by this is epsilon, because I'll just take all the length of ABC all together as 0. Any length is possible, any number of ABCs. Okay, if it is asked like the set of all strings consisting of at least one A followed by at least one B, at least one C, minimum one A, then B, then C. So what I have to do is A plus, at least, B plus, and then C plus. And set of strings consisting of at least one A. So I think I'll just tell you here, you can write in one more way also. The plus is nothing but A plus, I can write A star. B plus I can write the same thing, at least one A followed by any number of B's, at least one B, and then followed with at least one C. B star, C star. This is also correct. This both are same. Minimum one A, one or more number of A's. So here one A is there. After that, any number of A's. One or more number. If it is one A, okay. Or more number of A's. Star means if you want one A, make it epsilon. Or else if you want more number of A's, continue. So then what I'm trying to say is A plus is equivalent to A star. Like that. B plus equivalent to B star. C plus is equivalent to C star. Fine. Then how do you represent even number of A's followed with even number of B's? Even number of A's. So for the even to say, the minimal length could be either 0 or 2. So even number of A's. Don't say this is even number. Because if I take this is epsilon, this will be length 1. That is not even. So even number of A's in the sense A whole star. Even number of A's followed with even number of B's. If you want even number of C's to be followed, you write how many you want like that. So minimal is 0 length because star is there. Maximum is, it will start with, next length is always AA, multiples of AA together. Or else AA, 4 length. So 0 length, 2 length, 4 length. Like that it continues. So even number of A's followed by even number of B's. The next one is strings of A's and B's whose length is 2. Strings of A's and B's whose length is 2. Length 2 strings with A's, B's, combination length 2, right? Could be AA or AB or BA or BB. Any of this possible. Any of this means one or the other. R symbol plus. It could be AA plus AB plus BA plus BB. I can write one more way. This is length 2 in the sense this is length 1, this is length 2. If I multiply this, you will get the above. AA, AB, BA, BB. So strings of A's and B's of length 2. Fine. So how could you write the strings of A's and B's of length less than or equal to 2? Length less than or equal to 2. strings of A's and B's where its length is less than or equal to 2. So till 2 you have to write. So then it will include length 0, length 1, length 2 of A's and B's. So length 0 is epsilon, right? Length 1 is either A or B. Length 2 is, as usual, AA, AB, BA, and BB. So this is the answer for the length less than or equal to 2. Like this, plenty of questions may be asked, right? So this, how do you write? In a shorter way. I can write epsilon plus A plus B whole square with the length less than or equal to 2. If the length less than or equal to 2 has been written like that, how do you write the length less than or equal to 10? The same way, right? Just replace 2 with 10. Epsilon plus A plus B the whole power 10. So I think, do you have any doubts till today, this class?
Ma'am, I have a doubt.
Yeah.
Ma'am, what is the difference between A plus B the whole star and A star plus B star?
1 second. So you're asking this, right? A plus B the whole star. So this is A star, sorry, or B star. Actually, the difference is merely same, but the light one is, so here, so A plus B the whole star, it represents either A or B, right? 0 or more number of. I think no difference.
Okay, ma'am.
No difference. See, you may get, see here there is no constraint given that the number of A's has to be followed the number of B's. This is different actually. A star, B star is different. What does it say then? The plus means, I think, no difference. So star is, it is not a square to apply A square plus 2AB plus B square, right? It's just a star. So which is applicable to the A or B. Both are same.
Okay, ma'am. Thank you.
Both are same. I mean, any number of A's or any number of B's. My strings will be like this. Minimal epsilon string, or else the length one strings, if possible, I may get either A or I may get B. Either the string may start with A or the string may start with B. Correct? But in this case, it's not the case. Like here, what you do always?
B is followed by A.
Yeah, you will get only B. You will not get A. Suppose if the length is 1. You will get only A. You will not give, suppose the length restricted to 1. Right? Epsilon means leave it. Or else if the length is restricted to 2, you may get either AA. Here individually the restriction on A and B, right? Individually you have A star, B star. Suppose if you have something like this, AB the whole power star, it means that it always goes with the combinations of ABs. It is AB and then AB and then AB. It goes like that. If you give like that whole power star. But for A plus B the whole power star, as I said, it is same. Both are same. Still any doubts?
No, ma'am.
Fine. Okay, one second.